Hello student, today my lecture topic on postulate of quantum mechanics and physical significance of wave function. First, we will discuss the postulate of the quantum mechanics. What is the postulate? Postulate is a statement that accepted without any proof. Okay, so these are the postulate of the quantum mechanics. Postulate 1, a physical system is completely described by a wave function. This one. It is also quantum mechanical state of the system. Okay. Postulate 2. For every observable quantity can be expressed by operator in a quantum mechanics. Now, for example, here position observable quantity, the symbol is in a one dimension, it will be x, and in a quantum mechanics we can use a symbol like that, x like a cap, or upper side on the x is like that, is cap, and operation is multiplication by a x. Now in case of the 3D, we here small r, all of you know that r is ix jy in kz. In case of 3D, this position vector can be represented by a small r, and a cap like that in a quantum mechanics operator can be represented by like that, and the operation is multiplication by a r. Linear momentum. Okay. Now the x component of the linear momentum is px, is the observable quantity. In a operator, simply we will use a cap like that, and the operation is this one, I h cut, the first derivative with position. Okay. And all the components, it means that here all the components means px, py and pz will be presented by a p. Here we will use a cap like that, and here will be the operation like that, I minus I h cut, I divided by dx plus j divided by dy plus k divided by dz, and we can, all of you know that this delta is equivalent to these values. Okay, this is I h cut delta. Now, in case of the kinetic energy, here we can write the kinetic energy in case of the observable. In a classical mechanics, we can write p square by 2m, but in a quantum mechanics, we will use a cap on a k. Here k is the kinetic energy, and all of you know that here the operation of this operator is minus I h square by 2m is second derivative with x plus second derivative with y plus second derivative with z, and we can write that minus I h square minus I h cut square divided by 2m is delta square. All of you know that delta is this values. And the potential energy is denoted by a capital U, and the cap on a U is a symbol of operator in quantum mechanics. It will be simply multiplication by a U. And the total energy, there are two types of total energy, time independent and time dependent. In case of the time independent, total energy can be written as kinetic energy plus potential energy in case of the classical mechanics, but in the case of the quantum mechanics, we can write the operator like capital H, and we will use a cap on a capital H, and capital H is denoted by a Hamiltonian. This H is known as a Hamiltonian, and we can write that K cap plus U cap, and we can write that K plus U of these values like that. This is the operation of this operator. And the total energy, time dependent, we can write as E, and the cap of the E is the symbol of the operator in quantum mechanics, and the value of this one is I h cut for derivative with time. This one. Okay, these are the operators. Postulate 3. In any measurement of observable associated with operator. Suppose that A is any operator. Okay. Any measurement of observable associated with a operator, the only values that will ever be observed are eigenvalues like a small a, and that satisfy the eigenvalues equation. Here will be the eigenvalue equation when a operator A is operate of this wave function that will give a constant small a. This small a known as the eigenvalues, and this function is repeated itself here. This function is known as the eigenfunction, and A is the operator, and this relation is known as a eigenvalue equation. Okay. Here I am giving some example. You can understand very well what is the meaning of eigen equation. Now the eigen values equation, here we can write that operator operate on any function, it will give the constant and repeat the same function. This equation is known as a eigenvalues equation. Suppose that A is operate on a psi, they will give a constant values A, and this function will be same here, like the same function. This equation is known as a eigenvalue equation. For example, suppose that psi is equal to A e to the power ax. Now you will take the first derivative with position, you will get the value a e to the power ax and a psi. It means that dy by dx is the operator operate on this value and give the constant. This constant known as a eigenvalue. This one is the eigenvalue, and psi is this one is the eigen function. Okay. Now this equation is known as a eigen equation. Now another example, psi cos 3x plus 5. First derivative with position dy by d psi is minus 3 sin 3x plus 5. Now you will see here the first derivative operate on this function. You will see that you will give the constant minus 3, but function will be changed. It means that this equation is not valid for eigenvalue equation, and this one is not the operator of this function. Okay. In the sense of quantum mechanics, the operator of that function will follow this relation. Okay. It means that the second derivative of this function will give that minus 9 cos 3x plus 5, and you will see that here. Now you can say that here this equation is follow this relation. In a quantum mechanics, we can say that the second derivative of this function with position, they will give the eigenvalue minus 9. Okay. It means that this function will be same here after operate on this function. Otherwise this eigenvalue equation is not valid in the sense of the quantum mechanics. Okay. Now we will discuss the other postulate of quantum mechanics. Postulate 4. If a system is in a state described by the wave function, this one, then the average values of the observable is like that. Here you will write like that. This quantity is called expectation values or average. Now the function of any observable can be represented by like that here, and it will be equal to the integration of psi star a cap psi d tau. D tau is the volume element, like dx, like ds, dy and dz. And denominator we can write that the integration with minus infinite to infinite, psi star multiplied by psi is d tau. All of you know that, and this quantity is known as a probability. We will discuss later on. Okay. Now the average value can be written like that. And if the function is normalized wave function, if the function psi is a normalized wave function, now the denominator term is equal to the 1, and we can write that the average value is like that. This one is the postulate 4. Now we will discuss later on how this value is equal to 1 in case of normalized wave function. Okay. Postulate 5. The wave function or state function of a system evolves in time according to time-dependent Schrodinger equation, like that. All of you know very well. This one, time-dependent equation. Okay. And the postulate 6. The total wave function here, the total wave function must be antisymmetric with respect to interchange of all coordinates of one fermion with those of another. Suppose that here will be one fermion, there will be another fermion. You will change all the coordinates with respect to this fermion. Electronic spin must be included in this set of coordinates. It means that suppose that here will be a wave function like that, and you will change the coordinate, you will get another wave function like that. This wave function is known as a antisymmetric wave function. Now, when you will get this type of wave function for a fermion, you will include the electronic spin in the set of coordinate. Okay. These are all the postulates of the quantum mechanics. Okay. Now we will discuss the physical significance of wave function. Physical significance of wave function. What is the physical significance? All of you know that any wave, suppose that this psi xt, we will consider for 1D case. This is a wave function for 1D case. This wave function is describe the position of the particle with respect to time. Okay. And also this wave function is a complex quantity. So how can it correspond to real physical measurement of the system. Now the Max Born 1926, he is given the physical significance of wave function. According to the Born interpretation, the probability of finding the particle in a small length delta x at a position x and time t is equal to mod of psi square is delta x. Okay, this quantity is known as a probability of particle. Okay, and suppose that psi is, all of you know that psi is a complex quantity, so we can write that mod of psi square is like that, psi star into psi. We can write that psi star into psi is delta x is known as a probability. Now it means that psi xt, we will consider for one dimension, psi xt square is known as a probability density and square root of this function, like that square root of this function is equal to psi xt is known as a probability amplitude. Okay. Now suppose that the function of psi square with respect to the position present like that. Okay, and here you can see that here, suppose that this is A point, this one is a B point, and now this is the small length here like that. Now this is equal to delta x. This is a small length delta x. So now what is the total probability? The total probability from A to B, we can write that the total probability is equal to, like that, summation x is equal to A to B is psi xt mod of square is delta x. Also we can write that, suppose that this element is where delta x is extremely small, we will take the use of the integration A to B psi xt square into delta x. Now in this way we will calculate the total probability from A to B. Now suppose that the integration of mod in a all space, it means that the limit will go to the minus infinite to infinite, and dx and dt mod square if dx is equal to 0 or 0 and psi xt in dx is equal to 1. Suppose that the integration of overall space of delta space is equal to 0, it means that the particle not found. Okay, this because probability, the integration of the total probability is 0, it means that the particle will be not there. This value is equal to 1, it means that the particle is somewhere at all time. It means that the particle is somewhere at all time. Okay, and this condition is known as a normalization condition. Okay, so what is the normalization condition? Normalization of the wave function means you find the exact form of psi that ensure the probability that the particle found somewhere as space is equal to 1. Okay, basically we will use the exact form of the wave function. Okay, now in case of 3D, we will write here. Now in the case of 3D, we will write RT mod of square is equal to d tau is known as the probability that the particle will be found in a volume element d tau is equal to dx, dy, dx, dy and dz. Now we will write the normalization condition in case of 3D is like RT is square d tau is equal to 1. Now in the case of 3D, this is the normalization condition. Now you can understand in this experiment very well. Like this, suppose that we have a double slit experiment. Suppose that here a double slit like that, and here will be a screen. Suppose that here light is coming through the lens like that and incident on here on the double slit, and here we show the interference on the skin here. Suppose that here will be the amplitude of the wave function is like that with respect to screen, along the screen. Here will be the amplitude of wave function. Suppose that here we will show the nature of the wave nature of the amplitude on the screen, along the screen like that. Now, what is the intensity? All of you know that intensity is like that. Here, suppose that here will be intensity along the screen is like that. Here will be intensity. Okay. Now you can see here basically we will observe the intensity, not the amplitude. Okay. So the intensity is a reality. We will observe, not this part. And also we can write that here, all of you know that here the number of the photon on this axis is more, here 0, because the intensity is 0. Here a more photon, here will be a more photon, here will be a more photon. It means that here you can see that the intensity is a proportional to the square of the amplitude, and intensity is a reality. We will observe. And suppose that we will find the probability of the photon in this narrow region. So it means that the probability of the photon in this narrow region, we can write that like that is square is delta x. Suppose that this will be the narrow region is delta x. Here will be the probability of the photon. Okay. And all of you know that also. Now in this way we calculate the probability of the photon. In a wave model, the interference pattern in a term of wave intensity. Okay. Now what will happen? We will use a electron here, this slit, here will be a screen. You will see that here along the screen we will see that detector, we will detect a more electron, then again we will see the more electron, then will be more electron, then will be more electron. We will detect the probability of the finding the probability of the electron is like that, but we do not know the wave function of the electron. Only we know that the probability of like that. Only we know that the variation of the probability like that, which will be detected by the detector. Okay. Now in this case here, when we know that intensity, we can draw the probability of the photon. When we know that the probability of the electron, we will draw the intensity of the function is like that. Here will move like that here, and also we can draw the amplitude of the wave function is like that. Like that. Okay. Suppose that this one is a function of psi x. We can write that mod of psi x square is the intensity and the probability of the electron in this narrow region. We can write that mod of this x square is delta x is known as the probability of the electron in this case. In this way, we will use the analogy of concept of the light interference in case of when we will use the electron. Okay, because we have no idea about the wave function of the electron, but how we will calculate the probability? Now it means that probability makes a sense. Now it means that we can measure the probability, not the wave function. Here also you will basically here will be the now basically here will be the intensity is the reality. Okay, and according to the wave model, the interference pattern in a term of wave intensity. Now in this case, the particle model, the interference pattern is probability. Okay. Now it means that in this way we will find the probability.